Hi. Hi, I'm Andrew Chappell. I've been a professor for 5 years now. Like I said, this is going into my 5th year, and I'm going to be teaching you how to do data analysis in R, some basic kind of statistics here in this class. So this is just kind of an introduction, just to get you familiar with the Moodle, and then I'll make subsequent videos on each lecture. So let's kind of walk through the material that we have, just to give you an idea of, what this class is going to be like. So I have some information about me. You can see here, got a much nicer picture here. Just kind of information about me. I went to Rice University for my PhD. I went to LSU in Baton Rouge for my undergraduate. I'm born and raised in Louisiana, really prideful about working here and contributing to the health of people. I do a lot of research in orthopedics, OBGYN, cancer, and dental surgery, oral surgery. So I work in a lot of different areas. And, one of the things that's really cool about statistics is you get to, play in everyone's sandbox. That's a quote from the famous statistician Tukey. Now, I know most of you probably aren't going into statistics, but what I'd like for you to get out of this course is to get into the weeds enough with actually doing some data analysis to where when you work with a statistician in the future, you have a better understanding of what they're suggesting. And you also have a better understanding of questions that you might want to ask them to help your projects along or your research. So office hour information, you can see that here. I'm going to have office hours every Tuesday and Thursday, or every Thursday, sorry, from Zoom, from 2 p.m. to 4 p.m. Central Time via this link here. You can click this here. I actually generally wait until somebody joins in, so I get an email and then I'll pop in. So if you join the Zoom and I'm not there immediately, just give me a second and I'll hop in. And you can come in and you can ask about whatever you want. This is your time. You can ask about the lectures, you can ask about the homeworks, you can ask about your grades, you can ask about, any other things. Like if you're thinking about considering a career or whatever, that's your time with me. And anything that you ask me is fair game there. And also, I have here, if you're not able to make that time and you really need to meet to discuss something, just shoot me an email and I can set up an appointment to discuss. Or I can also answer things via email. So we can either meet via Zoom, but email me first to set up that time. So you're probably familiar with the Moodle page. This is it here, at least this is what I see. Let me turn my editing off. Let's see, getting started. So we're going to have a news and announcements forum. This will be kind of maybe changes in homeworks or clarification, things like that. That will all go on to these announcements here. We don't have anything right now. I also have this introduce yourself section. So I'd like everybody to come here and just tell me a little bit about yourself. And this is also a question and answer forum. So here you can ask questions here. And I can address those in the forum. So anytime you have any questions, feel free to ask. And lastly, we have the course syllabus, which I'd like to go through. So here's the course syllabus. This is, information here. I'll make every effort to respond within 24 hours. I'm usually pretty quick. So if you have a question, I generally get to it quickly. Catalog description is introduction to statistical concepts and data analysis methods with applications in experimental/health sciences. Topics include exploratory data analysis, correlation and regression, descriptive statistics, sampling distribution, statistical inference of estimation and hypothesis testing, including the t-test, the chi-squared test, ANOVA, some non-parametrics, logistic regression, and Cox regression. Next, we can see the learning outcomes. So these are the measurable outcomes that I'd like to see you learn in this class. When you complete the course, I'd like you to understand at least a little bit how math and probability play into data analysis. I'd like you to be able to execute some commonly used data analyses, methods, data summaries like plotting, doing summary statistics, t-tests, regressions, and categorical tests in R. I'm not expecting you to be an expert by any means. I'm just expecting, and I'm going to give you the tools here. We're going to walk through the coding, how to actually do some of these tests. So if you have a project on your own that you can work on, I highly recommend, and you should be able to do that. You'll have these resources. You should be able to always do that from here on out. Now, this isn't going to cover a lot of advanced statistical methods. And if you're doing some really serious research, I always advise talking to a statistician before you do anything. There's a famous quote, which is, if somebody comes to me after the experiment is done, I can only tell them what the experiment died of. So unfortunately, that's something I deal with a lot. A lot of people don't come talk to me before they get their data, and afterwards they can't answer the question that they want. So I'm not giving you the tools here to be a world expert in statistics. I'm giving you the tools here to do some basic analyses and understand what those analyses are, so you can better communicate with statisticians. You'll also be able to better read the literature because you're actually using these tests and talking about them. So that's the goal. Choose common statistical tests based on given data structure and inferential goals. Also identify shortcomings and when professional help is needed. So here are the modules here. Module 1, we have data, random variables, and statistics. So the goals here are to describe concepts related to random variables and list real-life examples of continuous or discrete distributions. The COI 1 means that it's related to this course outcome here. Second is perform basic descriptive statistics and graphs in R. So you'll get right into R from the beginning. We won't do any statistics. It'll just be, hey, take the mean, take the sum, things like that. So basic stuff in R, just getting yourself familiar. Understanding mathematical notation related to statistics, including means, Greek, variances, and products. That's going to be something we're going to discuss because I think it's important to understand how these formulas are computed. It may be scary at first to you, but I promise you, if you're patient with me and you believe in yourself, you'll be able to understand these things, even if you don't come from a good math background. Module 2 is just one sample test. So performing and interpreting a one sample t-test, Wilcoxon sign rank test, test of proportion, and chi-squared test. So these are one sample tests. This comes from, for example, okay, maybe I go out and I want to know, if the height of Louisiana self-identified males is on average 6 foot. So one sample test, I could actually test that hypothesis by going out and collecting a random sample. So going out and door to door, knocking on the door and asking, hey, do you have anybody in the home that identifies as male? If yes, they come out, I'll measure their height, and I do that repeatedly. And I can test whether or not the Louisiana male height is 6 foot there. Also constructing confidence intervals. So in interpreting in the context of hypothesis testing, so what is kind of the reasonable range of average male heights in Louisiana? When's it appropriate to use each test? Module 3 is going to extend this to 2 sample tests. So that would be multiple groups, 2 groups. So imagine instead of Louisiana males, self-identified males, maybe I want to compare heights of New Orleans males and Baton Rouge males. So that would be 2 different samples, and I could compare whether those average heights are the same or not. Perform and interpret 2 sample hypothesis tests, constructing confidence intervals for these 2 sample tests, and determining when it's appropriate to do each test. Module 4 is going to just extend this from 2 groups to multiple groups. So in the last example, right, I had New Orleans and Baton Rouge. Maybe I can add Lafayette and Shreveport into it. So compare all 4 of those cities' average male heights. Are they any different? So these would be ANOVA and Kruskal-Wallis tests. Also making pairwise comparisons, understanding type 1 error inflations. Module 5 is linear regression. So you probably heard of this. Estimate, graph, and interpret correlations between 2 continuous variables. So continuous variables would be something like height and weight. So your height, if you could measure it exactly, your height is continuous and your weight is continuous as well. Performing and interpreting multiple linear regressions. So that would be, how do multiple variables predict some kind of outcome? Maybe you want to predict weight as a function of self-identified gender, your height, how much you work out, what kind of diet you have. Those are things you can do. Perform ANOVA using linear regression and dummy variables. I don't want to explain that too much, but we'll get into it later. Module 6 is logistic regression, Poisson regression, and Cox regression. So linear regression predicts continuous outcomes like weight. If you know, conceivably, right, you can measure weight down to, 1.1 pound, like at the smallest scale. Logistic regression is for binary outcomes, which would be like predicting whether or not you live. So if I want to know, does a treatment improve a patient's chance of surviving, I'll use logistic regression for that. Poisson regression is regression for count data. So count data could be something like the number of children that a birthing parent has, or white blood cell count, or things like that. And Cox regression is for survival analysis. So Cox regression would be looking at, for example, what factors in terms of cancer therapy improve long-term survival overall. So not whether or not they died at a certain time, just overall, does treatments improve cancer survival times? How do you interpret results from the Cox regression? How do you interpret results from the logistic regression? Those are all the things we're going to be doing in Module 6. Now, it's going to be a very high overview in Module 6. I'm definitely not expecting you to be experts here. I'm just trying to give you a little bit of familiarity with what these things are, mostly because then you can kind of read the literature and understand a little bit more what's going on here. And then Module 7 is just going to be a big summary. So connecting the dots and moving beyond common methods. How do you interpret the results from Module 1 through 6? Can you understand the connections and the differences between the different methods that we talked about? And also know your limitations. So there's going to be a lot of assumptions that we have in this class. And these are going to be really common methods. But how to know when your data falls outside of one of these common methods and when you need help, and understand how a statistician can help these problems and how to communicate with them. Here's the course materials. Here I have you should download a copy of this R statistical software first. So this is a statistical program. And then you should also download R Studio, which you can see here. So these are both free software. We're going to be basically only using R. You might only need to download R Studio. Sometimes it'll download R for you automatically. But R Studio looks like this. We'll go into it a lot later, but you'll have plots and all these kind of things that will work through. And again, I'm not expecting anything from you as far as coding background. So don't be afraid of this. You totally can do it. Be patient with yourself. And you'll do fine in this class. So definitely download R Studio. It may download R for you first. It's been a while since I've downloaded it because I've had it installed for a while. If not, you're going to have to download R and then R Studio separately. Technical help. There's really nothing here. Grading coursework. Okay, I think I don't have this information. Grading breakdown. Okay, here's the grading breakdown. So grading breakdown, I have 7 assignments, homework assignments, 1 for each module. That's going to be 65 total points. We're going to have a midterm exam. I think that's in module 3, but I need to double check. I'll definitely give you a heads up. That's going to be 12 points. Your final exam is going to be 18 points. You're going to have 3 discussion forums that you're going to need to add discussions for. And you're going to have 1 quiz in this first module just to kind of get things off the ground. It's a requirement to have an assignment within a certain amount of time in the class, and this is going to validate that assignment. It's 100 points. I'll say classically, right, like I'm actually pretty easy grader. I think on average, I just taught a class this semester, a coding class. I had 8 students in the class, and all of them made A's. So I tend to have students perform really well in my class. I do ask a lot as far as homeworks, but I think if you really engage with the problems and you talk to me and ask me questions when you have them, you're going to do fine in this class. So I don't want you to be worried about it. That's really it. You'll have kind of information on how to submit it, when they'll be due, things like that. Course policies, these are the LSU handbook. I have a diversity statement here. So, we commit to representing a diverse background of students and, engaging with students from different backgrounds. So, I want to be inclusive and make sure that there's equity for different diverse backgrounds. You'll keep track of your stuff. The assignment dates are set in stone, and lack of attendance might lead to late assignments. Timely communication is best practice. Academic integrity. Okay, so this is, something really important here. You cannot copy work from other students. You can work together, that's fine, but you need to turn in your own work. So what you can't do is, if I'm working with another student and they write code to do the analysis, I can't copy paste that code and use that. Even if you're working together, your code should be different. You can talk to each other. You can, hey, this is how I did this problem. Oh, okay, this is how I did this problem. That's all fine, but you cannot identically copy from each other, okay? And neither can you identically copy from online. These need to be your own work. And actually, you probably won't find them online. All of the examples that I've made in this class are all examples that I've made myself. So, they're not things that you're going to find online. And I think you're robbing yourself if you do this. What you really want to get out of this class is trying to understand the concepts, engaging with me when you have questions, and I will be there to do that. Then we have, accessibility. If you have a notification of disability form, please let me know as soon as possible, just to give you an idea if, I need to give you extra time or anything like that. Netiquette. So this is just, general guidelines, be courteous, not just to me, to each other. And that's really it as far as the syllabus. So next lecture, we'll get into module 1. It's very nice to meet you all, and please feel free to reach out if you have any questions about anything. And again, my office hours in general will be Thursdays from 2 to 4 p.m. All right, see you next time.